In the late 1980s, Japan's major automakers made a quiet agreement. No production car would be rated above 276 PS, a ceiling negotiated among themselves before governments drew one for them. Then all four of them launched flagship sports cars at exactly that number. One of those cars was the Nissan 300ZX twin-turbo. Over-engineered, packed with technology, built at the height of Japan's economic boom when cost simply wasn't the priority. And for a while, that ambition paid off. But there's something Nissan never advertised about the 300ZX twin-turbo, and every owner eventually finds out the hard way. To understand that, you have to go back to the economy that made it possible. Japan in the late 1980s was operating in a different reality from the rest of the world. The Nikkei index climbed above 38,000 points in December of 1989. Land values in Tokyo had drifted so far from anything rational that the grounds of the Imperial Palace were, at least on paper, worth more than the entire state of California. Banks were lending against assets that were inflating by the week. Corporations were spending with a confidence that assumed the climb would never stop. Nissan was inside that environment completely. The engineers assigned to the Z32 project were given a brief that most automotive development teams never hear. Build the best sports car Japan has ever made. Cost is not the constraint. That directive matters because it explains everything that came after. The car they were replacing, the Z31, had drifted during its production run. It had softened. It had moved toward personal luxury at a time when Toyota and Mazda were sharpening their sports cars into something more focused and more aggressive. Nissan's product planning team recognized this as a problem, and the Z32 was the correction, not a refinement, a statement. So the engineers said yes to 4 camshafts, yes to sequential twin turbos, yes to 4-wheel steering, yes to electronically controlled suspension, and Brembo 4-piston front brakes as standard equipment, not as an option line on a window sticker. Every system that cost more than a simpler alternative was approved because the simpler alternative was not the point. The Z32 was designed in that environment, funded in the peak of the bubble when the approval for one more solenoid valve or one more hydraulic actuator carried no real financial weight. But here is where the story turns. The car was designed in prosperity and sold into collapse. Japan's asset bubble did not deflate slowly, it broke. The Nikkei peaked in December of 1989 and fell by nearly half within 2 years. Land values followed. The lending that had sustained the expansion dried up. Companies that had spent as though the growth was permanent suddenly found themselves in a very different conversation with their accountants. The first North American buyer took delivery of a Z32-300ZX in 1990. The bubble that funded the car they were sitting in had already begun to collapse. Nissan could not take the car back and redesign it. The 4 camshafts were cast. The sequential turbos were plumbed. The intake manifold was bolted over the rear cylinder bank, facing the firewall, blocking 3 of the 6 spark plugs from any reasonable access path. The engineering decisions made during the bubble years were now permanent features of a car being sold into a world with much less money in it. That is the central tension of the Z32. Not that the engineers made mistakes, they didn't. They built exactly what they were asked to build, and they built it brilliantly. The tension is that the world changed between the moment they designed it and the moment it needed its first service, and the car had no way to change with it. What Nissan built in 1989 was a machine tuned for silence on the road, with a soul the accountants would spend the next 7 years trying to price out of existence. The engine Nissan built for the Z32 was called the VG30DETT. That name is a compressed description of what it was. A 3-liter V6, dual overhead camshafts on both cylinder banks, 4 camshafts in total, 4 valves per cylinder, 24 valves across the entire engine, and 2 turbochargers working in sequence, one feeding from the other, in a system that required its own dedicated network of solenoid valves and vacuum lines just to manage when the second turbocharger joined the conversation. 300 horsepower, 283 pound-feet of torque. Those numbers need context. The year was 1990, and the sports car world was in the middle of a serious conversation about what a performance car could be. Honda had just launched the NSX. Toyota was preparing the A80 Supra. Mitsubishi had the 3000 GT VR4. Nissan in Japan had the Skyline GTR. 4 manufacturers, 4 flagship sports cars. Every single one of them arrived with an official rating of 276 PS. That is not a coincidence. The Japanese domestic market had an informal agreement, not a regulation, not a law, but a coordinated understanding that no production car would be officially rated above 276 PS. The concern was a domestic horsepower race that might invite government regulation. So, all 4 manufacturers agreed on a ceiling, and all 4 launched their flagship sports cars at precisely that number simultaneously. The North American rating of 300 horsepower reflects a different measurement standard rather than a different engine. The coordination is visible in the ratings themselves. Motor Trend watched all of it and named the Z32 their import car of the year for 1990. That recognition was based on the full package: 0 to 60 in approximately 5 seconds, quarter mile in approximately 13.5 seconds, braking and lateral acceleration that period tests placed above the Porsche 944 Turbo, and a technology stack: 4-wheel steering, electronically controlled suspension, Brembo 4-piston front calipers as standard equipment that felt at least a decade ahead of what the price should have bought. The sequential turbo system is the feature that made the VG30DETT feel unlike anything else in the class. Below roughly 3,500 revolutions per minute, only the front bank turbocharger was active. The rear bank turbocharger stood by, bypassed, waiting. Then above that threshold, the solenoid valves opened, exhaust gas reached the second turbocharger, and the driver felt a distinct step in thrust. Not a smooth power curve, a step. A moment where the car changed character mid-acceleration. Something a single turbo or naturally aspirated car simply could not replicate. The engineering team built the brakes to match what the engine could do. They built the suspension to match the brakes. They built the 4-wheel steering to manage the chassis loads the whole system could generate. Nothing was left as an afterthought. The directive was simple: perfection, not profit. And for 1 year, in 1990, looking at the award on the wall and the press coverage in the magazines, it genuinely looked like they had achieved it. But achieving 300 horsepower in a compact body requires fitting 4 camshafts, 2 turbochargers, and all the plumbing that connects them into a space that was never designed to be generous. And in the process of solving that puzzle, the engineers made one packaging decision that would cost every future owner more than they expected. The VG30DETT sits transversely in the Z32's engine bay, sideways, with the engine's length running across the car rather than front to back. It helped distribute weight evenly between the axles in a compact body. It contributed to the balance that made the car handle the way the period tests described. It also pointed the intake manifold directly at the firewall. On a transversely mounted V6 with a 60-degree bank angle, the rear cylinder bank faces rearward. The intake manifold sits between the 2 banks, positioned toward the back of the engine bay, toward the least accessible part of the entire car. Behind that intake manifold sit 3 spark plugs, facing directly toward the firewall, with no clear path to reach them without first removing what is in the way. What is in the way is the intake manifold. Nissan's own service manual documents what this means in practice. To replace the rear cylinder bank's 3 spark plugs on the VG30DETT, the procedure requires disconnecting the intake air system, the fuel rail, the throttle body, and a collection of vacuum lines before the manifold can be lifted free. Once the manifold is removed, the rear plugs become accessible. The manifold then goes back on with new gaskets because the old ones are not reused, and every fastener is torqued back to specification. The service manual's labor time estimate for a complete 6-plug replacement is approximately 8 hours. That figure comes from Nissan, not from a mechanic complaining about the job, but from the factory documentation given to every authorized dealer. At independent shop rates of $75 to $100 per hour in the mid-1990s, 8 hours produced a bill of $600 to $800 before a single part was purchased. Most owners deferred it, not from neglect. Most understood the car they had. But the cost created a threshold that a meaningful number couldn't or wouldn't cross on schedule. So the plug stayed in a little longer, and then a little longer after that. When spark plugs wear past their service point in a turbocharged engine, the ignition coils work harder to fire across a wider gap. More stress leads to coil failure. A failed coil under boost produces a misfire. And misfires in a turbocharged engine create combustion irregularities the engine was not designed to absorb regularly. Deferred plugs stress the coils. Failed coils caused misfires. Misfires stressed the engine. A fundamentally sound engine began accumulating damage, not because of any flaw in its design, but because the cost of accessing it had pushed routine service out of reach. The engineering team that built this car also wrote the service documentation. They described the removal sequence in precise detail, specified torque values, noted the gasket replacement requirement. They knew exactly what the rear spark plug procedure involved, which means they knew what they were asking every future owner to pay. That was the trade the engineers made: performance over serviceability, balance over access. It was a reasonable trade in 1989, when cost was not the constraint. It became an unreasonable one every year after that. The spark plug problem was not the only place the Z32 punished deferred maintenance. It was just the most visible one, the most documented, the one that showed up on the estimate sheet before any other work began. But the car had more ways to become expensive. The sequential turbocharger system that made the VG30DETT so distinctive was managed by a network of solenoid valves and vacuum lines. Small valves, controlled electronically, deciding when to open the path to the second turbocharger and when to keep it closed. Below roughly 3,500 revolutions per minute, the system held the second turbo in reserve. Above it, the solenoids opened and the second turbo joined. That handoff, that step in thrust the driver could feel, depended entirely on every solenoid in that network doing its job correctly. They are 30 years old now. Heat cycling degrades solenoids. Rubber vacuum lines harden and crack with age. When one solenoid in the network begins to fail, the symptom is not a warning light and a clear diagnostic code. The symptom is that the car does not behave the same way above 3,500 revolutions per minute. The second turbo engages late, or inconsistently, or not at all. Boost pressure becomes irregular. The power delivery that defined the driving experience starts to feel vague and unpredictable. Diagnosing which solenoid in a complex network has failed requires systematic testing, the kind of methodical process that a general import shop without Z32 specific experience will struggle to complete efficiently. Each individual solenoid is not expensive to replace. The labor to find the failed one is what the bill reflects. Then there is HiCAS. The HiCAS four-wheel steering system was one of the features that separated the Z32 from everything else in its class at launch. Hydraulic actuators at the rear steering rack steered the rear wheels in the same direction as the front wheels at high speed and in the opposite direction at low speed, tightening the turning radius and improving stability simultaneously. On a fresh system in 1990, it worked exactly as intended. The failure mode is hydraulic. The rear steering rack seals age. Fluid depletes slowly, quietly, without any obvious external sign until the system's behavior changes. And when the hydraulic pressure drops below what the actuator requires, the rear wheels do not steer as commanded. They steer unpredictably. The NHTSA complaint database for the 1990 through 1996 300ZX documents this as a consistent concern across multiple model years. Not a fringe failure, a pattern. A failing HiCAS system does not just reduce the car's cornering capability. It steers the rear wheels in ways the driver does not expect, at speeds where the consequences of unexpected rear wheel movement are serious. The documented solution in the Z32 owner community is a conversion that permanently eliminates the hydraulic system entirely. A solid steel bar replaces the rear hydraulic rack. Fixed tie rods lock the rear wheels in a set position with no active steering input at all. The high-cast warning light illuminates on the dashboard afterward and stays on, but the unpredictability is gone. The failure mode is gone with it. Multiple companies manufacture and sell this conversion kit commercially. That market exists because the demand for it is consistent. And the demand is consistent because high-cast hydraulic seal failure on a 30-year-old car is not a rare event. It is an expected one. The manual transmission had its own concerns. The twin-turbo's torque delivery, that step change from single-turbo to twin-turbo operation, accelerated synchronizer wear over time at a rate higher than the naturally aspirated application of the same gearbox. Not a catastrophic failure, a gradual one. A car that eventually begins to resist clean shifts in specific gears, requiring a rebuild that adds another line to an already long invoice. None of these systems were unreliable by design. The turbochargers themselves, when oil change intervals were maintained, are durable units. The high-SAS system functioned correctly when it was new. The solenoids held their calibration for years before age changed the equation. The problem was never the ambition of the engineering. The problem was the cost of sustaining it across decades in a world where the bubble money was long gone. To understand why the Z32 became commercially unsustainable, you need to understand what happened to the yen 5 years before the car reached a showroom. In September of 1985, the finance ministers of 5 major economies sat down in New York at the Plaza Hotel and agreed to intervene in currency markets. The goal was to weaken the dollar against the yen and the Deutsche Mark, correcting trade imbalances built up through the early part of the decade. The agreement was called the Plaza Accord, and it worked. The yen moved from approximately 240 to the dollar in 1985 to approximately 128 to the dollar by 1988. Nearly double in value in 3 years. What that means for a Japan-assembled car sold in North America is straightforward. If Nissan needed a certain number of yen to build the Z32 at the Optima plant, and the yen now bought nearly twice as many dollars as before, the dollar price of that car had to rise to keep pace. No manufacturer absorbs a near doubling of their currency's value without passing a significant portion of it to the buyer. The Z32 twin-turbo launched in North America in 1990 at approximately $27,300. That price was already at the upper boundary of what the sports car market would accept for a Japanese nameplate. The performance justified it. The Motor Trend Award helped, and for 1 year, the value proposition was genuinely compelling. Then the years passed and the yen stayed strong. By 1993, the twin-turbo's price had climbed into the $33,000 to $35,000 range. That same year, 2 new cars arrived in North America that the Z32 had not faced at launch. The Toyota Supra Turbo, powered by the 2 JZG-TE straight 6 with 320 horsepower, lighter and more focused than the Z32, and the Mazda RX-7 in its FD generation, 255 horsepower, rotary engine, a weight figure that made the Z32 feel heavy by comparison. Both of them entered the market at prices that overlapped directly with the Z32. Both of them received consistent press attention that emphasized what they did better. And the Z32, which had been the benchmark 3 years earlier, was now one of 3 serious options rather than the clear choice. By 1996, the final year of North American production, the twin-turbo's price had reached approximately $39,000. $39,000 placed the Z32 in direct comparison with the Dodge Viper and the Chevrolet Corvette. American cars with American brand familiarity, American dealer networks, and American parts costs. A buyer in 1996 looking at a nearly $40,000 Nissan with an $800 spark plug service interval had real alternatives at the same price without that maintenance overhead. The value argument had been eroded from both ends. The purchase price climbed because the yen never gave back what the Plaza Accord took. The maintenance cost was baked in from the first day. The engineering was the same as it had always been, unchanged, exactly as brilliant, and exactly as demanding as the day it left the Optima plant. The world around it had simply run out of patience for what it cost. Nissan withdrew the 300ZX from North America after the 1996 model year without ceremony. There was no farewell edition, no special badge, no commemorative trim package. A market withdrawal, the kind of quiet exit that happens when the commercial case has already been lost. And the only remaining question is when to stop, not whether to. The dealers sold their remaining inventory. The last buyers took delivery. And the Z32 was simply gone from North American showrooms, replaced by nothing, with no announced timeline for what might come next. Japan continued limited Fairlady Z production through the year 2000. The name the car had always carried at home, taken from a Broadway musical that Nissan had used to market the original Roadster to American buyers back in the 1960s, never once used in North America for any generation of the Z car. The people who built it called it something the people who bought it never heard. But in North America, there was silence. 7 years of it. The Z33350Z did not arrive until 2003. That gap is not a marketing strategy, not a deliberate pause to build anticipation. It maps almost exactly onto the worst financial period in Nissan's modern history. And that alignment is not coincidental. The bubble that had funded the Z32's development had already collapsed before the car reached its first owner. But the full financial consequences of that collapse took years to work through the system. By the late 1990s, Nissan was carrying debt that had become unsustainable. The company had not yet secured the Renault partnership that would eventually provide the capital for reconstruction. There were no surplus development resources being held in reserve for a Z32 successor. The resources required to develop that successor simply did not exist. In 1999, Carlos Ghosn arrived with the Nissan Revival Plan. 5 plants closed, purchasing costs cut significantly. Cost discipline imposed across every product line, every development program, every department that had previously operated with the kind of financial latitude the bubble years had encouraged. The Z32 was the last Nissan sports car built before those rules changed. 4 camshafts, sequential twin turbos, Heikes 4-wheel steering, Brembo brakes as standard equipment, electronically controlled suspension, all of it simultaneously in one car, at a price point below $40,000. No Nissan product developed under the Revival Plan's cost constraints carries that combination. Not because the engineers who came after were less skilled or less ambitious, because the financial environment that approved every one of those decisions in 1989 had been replaced by a different conversation entirely. The Z car came back only after Renault's investment provided the resources to develop a successor. The 350Z that arrived in 2003 was a good car, a focused car, a car that understood its cost constraints and worked within them honestly. But it was a different kind of car from the one it replaced. Everyone who had owned a Z32 knew it the moment they sat in one. The cars that made it through are worth understanding on their own terms. The VG30DETT is a fundamentally sound engine. Owners who accepted the spark plug, labor cost on schedule, replaced the timing belt at the correct interval, and changed the oil consistently have documented examples running past 150,000 miles. The engine itself did not fail them. The maintenance cost barrier filtered out low investment owners, and what remained was a fleet disproportionately maintained by people who were serious about what they owned. The surviving Z32 population is in better average condition than it would be if the car had been cheap and easy to maintain. The Z32 repelled casual ownership. Every owner who stayed was an owner who paid the bill more than once, knowing exactly what the next one would look like. The specialist community that built up around the Z32 is part of what made survival possible. Not just forums, but dedicated shops that accumulated the specific tooling and procedural knowledge the car requires. Technicians who have done the rear spark plug sequence enough times to have developed their own efficient approach to it. Suppliers who manufacture the high-cast elimination kit, replacement solenoids, and timing belt component set specifically for this platform. That ecosystem did not exist in 1990. It grew because the car needed it, and enough people cared enough to build it. The high-cast elimination conversion, that solid steel bar replacing the hydraulic rear rack, became a de facto standard in the committed ownership community. Not because the four-wheel steering wasn't remarkable when it worked, but because a car with no rear-wheel steering is predictable, and predictable is what you want from a machine you plan to keep. The owners who performed that conversion removed the failure mode permanently, and then moved on to everything else the car needed. Collector values have strengthened as the model's distance from production has grown. Low-mileage twin-turbo coupes in documented condition now command prices that justify the maintenance investment. When the price reflects genuine rarity and historical significance, the owners who pay it maintain accordingly. There is also the matter of the 1996 transition to OBD2 engine management. The final year of North American production received updated engine management to meet the new standard, creating a specification distinction between the 1990 through 95 examples and the 96 cars. That distinction matters practically for anyone sourcing a replacement ECU today. It is the kind of detail that separates an informed buyer from an expensive mistake, and the specialist community has documented it thoroughly. The Z32 sits at an intersection that no other car occupies in quite the same way. It is the last product of bubble-era engineering ambition, built when the directive was perfection and the financial ceiling did not exist. And it is the last Nissan sports car built before the Revival Plan changed what the company was willing to approve. What it means is not that the engineers failed. They didn't fail. They succeeded completely by every standard they were given. The performance was real, the technology was genuine, and the engineering was as thorough as anything produced in that era. What it means is that they succeeded in a world that lasted about 12 months before changing into something the car was not designed for. And the gap between what they built and what the world could sustain is the whole story. That gap never closed. The bubble funded it. The Plaza Accord priced it. And the intake manifold made it impossible to ignore. But here is what that gap actually tells us. 4 Japanese manufacturers sat in a room and agreed on a ceiling, 276 PS, because they were afraid a horsepower race would invite government interference. They were building machines so capable they had to restrain themselves. That is the world the Z32 came from. Engineers who were genuinely concerned they were making things too powerful. Accountants who had not yet won the argument. Today that conversation runs in the opposite direction. The horsepower numbers are bigger, the screens are larger, and the service intervals are longer. Because modern cars are designed to minimize the moments an owner has to think about what is underneath the hood. The complexity is still there. It is just hidden behind software instead of solenoids, managed by systems that send a code to a dealer tool instead of requiring someone who actually knows the car to diagnose it methodically. The Z32 was expensive to maintain because it was honest about what it was. Every dollar on that spark plug invoice was a direct reflection of the engineering underneath it. $800 told you exactly how seriously the people who built this engine took 4 camshafts, 2 turbochargers, and the packaging decisions required to make them fit. A car that costs nothing to ignore until it is worth nothing is not a better car. It is a more convenient one. There is a difference, and the people who kept their Z32 running understood it clearly. The last of the greats were not cheap to keep. They were worth keeping anyway. Now, click on this next video. If you want to see how, in 1989, Toyota did something no one thought possible. They built a luxury car that outperformed Mercedes and BMW and cost half as much. This is the story of the Lexus LS 400, a car built when durability mattered more than profit margins, and why that philosophy has been largely abandoned.